Hey everyone, welcome back to my channel. I'm Neil and in today's video, I'm going to talk about congruent and similar triangles, how to spot them, understand the rules behind them, and use them to solve problems like a pro. If you want to boost your geometry skills and feel more confident in exams, you're in the right place. Before we jump in, make sure to subscribe because I'll be covering more about this topic in upcoming videos. And if you found this video helpful, don't forget to give it a thumbs up. Thank you so much. Okay, we are talking about congruent triangles. What are congruent triangles? In fact, two triangles are congruent if they are identical in every aspect except for position. As an example, you can see we have triangle ABC and triangle NMP. And you can see that there are three pair of equal sides. AB equals MN and AC equals PN and BC equals MP. And the same story for angles. Angles A equals N, angles B equals angle M, and angle C and P are equal in size. So we found that triangle ABC is congruent to NMP. In fact, they match each other perfectly. And how about these two triangles? So we have triangle ABC, and you can see that we have two sides BC and EF. Both of them are 3 centimeters. So BC equals FE 3 centimeters and AB equals DE 4 centimeters, and third side is AC and the corresponding side is DF, which is 6 centimeters. So this is about sides. And how about angles? Angles A equals D 50 degrees and angle B equals E 70 degrees, and the last one 60. Angle C equals F, which is 60 degrees. So because of that, triangle ABC is congruent to DEF. So far so good. There are some tests for checking or proving the congruency of two triangles. In fact, two triangles are congruent if one of the following is true. The first one is SSS, which is the abbreviation for side, side, and side. In fact, all corresponding sides are equal in lengths in these two triangles. So you can see that we have one pair of sides with length 3 centimeters and then with 4 centimeters, and the last pair of sides is 5 centimeters. So if we have this situation, so because of SSS fact, we found that these two triangles are congruent. And the next one is SAS, which is the abbreviation for side, angle, and side. And you can see these two triangles. In fact, two sides like 2 and 2 and 5 and 5 and the included angle, I mean this angle between these two pair of sides, are equal. Two sides and the included angle are equal. So we call this SAS. The third one is AA corresponding S, which is angle and side and angle. Two angles and a pair of corresponding sides are equal. So as you can see, we have these two pairs of angles which are equal in size, and the side between them. Last but not least, RHS. Okay, this is the abbreviation for right angle triangle. H is hypotenuse and S is for side. And the example is this. In fact, for right-angled triangles, the hypotenuses and one other pair of sides are equal. So you can see that both of them are right-angled triangle, and the hypotenuses are equal in lengths, and another side, another pair of sides, which is here, are equal. So it refers to RHS. Okay, after knowing these four tests, we can find out the congruency of any two or more triangles. Okay, we have an example, and the question is, are these two triangles congruent? And if so, what can we find about DE? Where is DE? DE is here. Okay, so first of all, I can see that we have one pair of sides, equal sides. BC equals to DC. So BC equals DC because they are given that are equal. And the next one is AC and CE. AC equals CE for the same reason, they are given. And after that, I have this side AB, but we don't know the value, the length of DE, so we cannot write AB equals DE. So we should go for, instead of sides, go for angles. Okay, we don't know the size of any of these angles, but we know that we have these two angles which are equal. Why? Because they are vertically opposite. If you don't know what are they, so I can say that when we have two straight lines that meet each other in one point, this is the intersection point, so we have four angles here, 1, 2, 3, and 4. And angle A equals angle D because they are vertically opposite. And the same story for angle 3 and angle 4. So we call these vertically opposite angles. So I use this rule to write the third fact of the congruency of these two triangles. For this one, I can say ACB, angle ACB, and for this one, I'm gonna say ECD. So the reason is they are vertically opposite. Okay, so you can see that this is side, and this is the angle between these two sides. So the fact is SAS. So we found that triangle ABC is congruent to EDC. And what can we find about DE? Okay, and now after that we found ABC is congruent to EDC, other, that are left, for example, DE and AB are equal as well. So consequently, the remaining side is DE and AB are equal, which is 2 centimeters. And the next one is that we can find 2 other pair of angles are equal as well. Let me show you using this color. This angle and this one. Let's call them, the first one is BAC. BAC equals CED. CED. Okay, and now because we have 2 lines, let me write this here. AB, and here is DE, and we have a transversal line here, so we have these 2 angles, this one and this one. Because these 2 angles, BAC and CED, are equal, they are alternate angles. We found that these 2 lines are parallel. I mean, AB is parallel to DE because this is a transversal line, and these 2 angles here and here are 2 alternate angles which are equal. So using this rule, I found that AB is parallel to DE. The question was, what can be found about DE? We found these 2 things. DE is 2 centimeters and AB is parallel to DE. Okay, and another example. We have this figure. This is a triangle ABC, and there is a line between them, AC, and we are asking to prove ABC, why ABC is congruent to ADC. In fact, we have 2 triangles. Let's bold them. The first one, the pink triangle, and the second one is a green triangle. So far, so good. Okay, so I know that AB equals AD. It's a given. And BC equals CD, the same reason. And now you can see that this line, in fact, this line belongs to this triangle and this triangle as well. So this is a common side between these 2 triangles. So AC is a common side. So we use 3 equal sides, SSS, and we find that ABC, for this reason, is congruent to ADC. Another thing that I'm going to find about this question is that these 2 angles, this one and this one, let's call this C1 and C2, they are equal in size because C1 plus C2 is a straight angle. They add up to 100 degrees, so C1 and C2 are 90 degrees. So we found that AC, which is the height of this isosceles triangle, is perpendicular to base BD. So there is an important fact in these questions, which is the height of an isosceles triangle here, the height of an isosceles triangle drawn from the vertex angle to the base is the perpendicular bisector of that base. So AC is the perpendicular bisector of the base, which is BD. AC is perpendicular to BD. This is really important. And the last question for this session. We have two circles, the smaller one and the bigger one with the same center. And AB is a line which is perpendicular to the smaller circle. And we are asking to prove that P is the midpoint of AB. In fact, we are looking for why AP equals to PB. Why? Okay. So we have two triangles. The first one is this, OAP, and the second one is OPB. And I'm gonna prove that these two triangles are congruent. Okay, the first reason is OA equals OB. Both of them are radius of the smaller circle, so they are equal. And then OP is common side. Okay, and I'm going to use a fact in this case because we have AB is a tangent to this circle. When we have, let me write here. When we have a circle and a line which is tangent to this circle, we can draw a radius, and this radius R is perpendicular to the tangent in point of tangency in P. And if you call this D, R is perpendicular to line D because this is a point of tangency. So I'm gonna use this fact. So we have a right angle here and here. You can call this P1 and P2. So in fact, these two triangles, OAB and OPB, are right angle triangle. Okay, so according to this fact, which is a right angle triangle, we have OA and OB, okay, both of them are hypotenuse, H, and a side which is OP. So RHS is the reason for congruency of OAP and OBP. Okay, so consequently, AP from the green triangle equals PB from the red triangle. So in fact, we proved YAP equals PB, and AP is equal to PB, so P is the middle point of AB. Okay, so this rule is really important, and we can use this for solving such questions. A radius is perpendicular to the tangent. Radius perpendicular to the tangent in the point of tangency. Okay, I hope you enjoyed this video. See you in the next one. Bye-bye.